lecture is about maxima and minima. These are the extreme values of the function for BSC. Extreme values of a function. This is related to our calculus and analytic geometry chapter 7.2. For this theory is that for a given function technique for finding extreme values of the function. If we have graph of the function y is equal to f of x like this, then at certain stages graph has maximum value, at another stages it has minimum values, and there are certain points, and cross denotes a point of inflection. In this lecture, I will briefly describe how to find the extreme values of the function. Step 1 is for a given function f of x, y is equal to f of x, find first derivative y1 f dash of x and put it equal to 0, get some values of x is equal to a1, a2, a3, etc. Now there is step number 2, find y2. This is the second derivative test, and x is equal to a1. If second derivative is greater than 0, then f of a1 will give minimum value, and x is equal to a2. If y2 is less than 0, then f of a2 will give maximum value, and x is equal to a3. If second derivative is not greater than 0, not less than 0, but equal to 0, then this particular point a3, f of a3 will be the point of inflection. These are very interesting questions. I will take one question. If you have given function like this, locate the points of maxima or minima, and find their values. If we have a function like this, f of x is equal to y is equal to x cube minus 3x plus 5, then step 1 begins over here. Find out y1. First derivative will be 3x square minus 3. Put this first derivative equal to 0 like this. You will get the very easy two values of x. X square is equal to 1 and x is equal to 1 and x is equal to minus 1. Now very simple, take the second derivative y2. It is 6x. And x is equal to 1. And x is equal to 1. Find out the value of second derivative by putting over here. y2 is equal to 6 cross 1 is equal to 6 greater than 0. So x is equal to 1 is the point of minima. And if we get minimum values, then minimum values are obtained from the original function where it is given over here. Write 1 instead of x like this, 6 minus 3, 3, and x is equal equal to minus 1. You see over here, second derivative behavior is like this, and it will become minus 6 less than 0. This will become maximum. X is equal to minus 1 is the point of maximum, and how will you get maximum value? Maximum value will be like this. Maximum value will be f of minus 1. Just put over here minus 1 raised to the power 3 minus 3 into minus 1 plus 5 minus 1 plus 3 plus 5 5 minus 4 plus 3 into sum. The question is over. Now all the values of x are utilized, maxima and minima have been found, and next lecture I will brief about the points of inflection. So I think this lecture will be